On number 51, we want to factor x to the fifth minus 81x. Now, like I always recommend, we should look for something we can factor out of everything before we start trying to do a difference of two squares or anything else like that. So looking at this, I can take a GCF, a greatest common factor, of x out. And have x to the fourth, because x times x to the fourth would give me back my x to the fifth, minus 81, because x times negative 81 would give me back my negative 81x. Okay, so we look at what's left, x to the fourth minus 81, and we say, can we keep factoring that? And the answer is yes. It certainly looks like we might be able to, because it's two terms being subtracted, so it might be a difference of two squares. So let's write the template for it, right? Something squared minus something squared, and fill in the blanks. Well, the second one's probably easier. 81 is 9 squared. X to the fourth, as we saw in class, is x squared squared. So really, x to the fourth minus 81 is x squared squared minus 9 squared. So we have something that's of the form a squared minus b squared. So this is a difference of two squares, where a is x squared and b is 9. So I'm going to have x times a plus b, x squared plus 9, a minus b, x squared minus 9. Now I need to keep looking because x is already factored all the way. I can't factor x squared plus 9 because it's a sum of two squares. There's no formula for factoring that. But x squared minus 9 is another difference of two squares. So I can factor it even more. Right? That would be x squared plus 9. This is something squared minus something squared. In fact, it's x squared minus 3 squared. So in this case, my a is x, my b is 3. So I can factor that as x squared plus 9, times a plus b, x plus 3, times a minus b, x minus 3. And that would be the complete form you can factor because none of those individual factors go down anymore.